Hello everyone, welcome to the channel Statistica Hub. This is our lecture number 3 in the course SH201A. Okay, so in the earlier two lectures, we have discussed something about the probability, some basic introduction about probability and some different definitions of the probability. Now in this lecture, we are going to cover something that is known as combinatorial analysis. So in this particular part, we are going to discuss majorly about combination and permutations. Okay. Now the point is like, what is this particular kind of analysis? Like, what is the like? Do we have something that is very different from mathematics or statistics, or is it like a combination of all these things? Or like, what is the combinatorial analysis? So basically, in the very simple format, this is a branch of mathematics. So this is a branch of mathematics that deals with counting, arrangements, and grouping of objects. Grouping of objects. Okay, now the point is like, why is it required to understand the combinations and permutation in our course of like probability theory? So the point is like, if I go for the last lecture, the lecture number 2, we have covered the classical probability, that probability of any event A that will be number of elements in A over number of elements in sample space S. Okay, the examples that we took, they were like very simple, like tossing up a coin, okay, rolling a die. So like straightforward examples, like you could simply see that, okay, we are going to toss the coin, there will be like head or tail, two outcomes are there. But what if we are having like much advanced course, much advanced experiment, in which we won't be able to see like the possible number of outcomes like in one go. So to tackle with these kind of problems, we have to understand the methods that we are going to deal in combination permutation. Okay, so there will be like, basically we have two different, so two principles. We have two principles of counting. Okay, the first principle that we have to consider, that is principle of addition. And the other thing that we have is the principle of multiplication. Okay, moving to the concept of like principle of addition. So like without going to like much in the detail, I will go for like very generic, very easy format. So just remember this one case, when there is like some cases that are formed, cases formation. In that case, we go for principle of addition. And in this one, when the case is something about simultaneous occurrence, then we go for principle of multiplication. Okay, so what does that mean? Like we got some idea that we are having two principles for counting, addition, multiplication. Then I wrote very generic form. When there is some case formation, we go for principle of addition. When there is like simultaneous occurrence of some event, then we go for principle of multiplication. Let's try to understand like it in a more like more detailed format. So if I go for like principle of addition, so we have principle of addition. Okay, so let's say you are having some event A, and if this event can occur in M ways, okay, we have some event B, and this can occur in N ways. Okay, so if the event A that can occur in M ways, and the event B that can occur in M ways. Okay, what about this then? Then, and there is like one more condition, that they don't occur, they don't occur simultaneously. So this is some given condition that we are having two events, event A, event B, and event A can occur in M ways, B can occur in N ways. Now, if I say total number of ways, total number of ways in which A or B occur. So we have to deal with this type of setup. So like either A can occur or B can occur. So A can occur in M ways, B can occur in N ways. So the answer to this problem, that will be M plus N. Very simple, very simple. Okay, now if I say, like, for example, if you can consider like maybe a very simple example, let's say you are having some bag, and in the bag you are having maybe 5 red balls. Okay, you may be having 3 green balls. Now if I say what number of ways to get a red or green ball. So that will be simply red can occur in 5 ways, green can occur in 3 ways. So that will be 5 plus 3, simply we are getting 8. Okay, very simple concept, the concept of like the principle of addition. Okay, moving to the next concept, second principle that we have, that is the principle of multiplication. Okay, now assume the same thing, that we are having some event A, and this event can occur in M ways. Okay, event B that can occur in N ways. Okay, now in this particular setup, if I say that the number of ways in which both A and B can occur, so we have to go for number of ways in which both A and B can occur, A and B. So in this setup, let's say A, the first position for A. So let's say A is having like the first way. Okay, so for the B, there can be the first way, there can be the second way, and there can be the nth way. And similarly, it can be filled by n ways, and again you can have A that can be the second way. So B, again it can be filled like the n ways. In total, the A can be filled up by m number of ways. So finally, you are going to get m into n ways. That is like principle of multiplication, a very simple concept. Okay, now again you can think about one example. Let's say you are going for some party, and you are having maybe 5 number of pants and 3 number of shirts. Okay, so usually people are having like different setup. So you can have like 5 number of shirts and 3 number of pants, maybe the jeans. Okay, so how many combinations can be there? So with the first pant, you can have 5 shirts. With the second pant, you can have 5. With the third, you can have 5. So finally, total number of pairs that we are going to get in this case, that will be coming out to be 5 into 3. That is 15. Very simple, the principle of multiplication, and we covered the principle of addition. Okay, now let's move to the next concept, that is about permutation. Okay, just understand the meaning of permutation and combination. That's it. Very simple concept. So if I go for like permutation, okay, I will not write the proper definition like what is the meaning of permutation and everything. I will simply go for like arrangement. You have to make some sort of arrangement in this case. Okay, and in this particular property, the permutation, the order matters. Like in which order you are arranging the objects, that ordering the sequence that matters in this case. So if I go for maybe we are having n objects, and you have to arrange them. So first place, second place, third place, and so on. Finally, you are having the nth place. So the first place, it can be filled by any one of the n objects. So we are having n position or n possible things. For the second place, one object has been taken up. So we are left with n minus 1, then n minus 2, and finally there will be 1. So this is coming out to be n factorial. Okay, very simple thing. We are arranging the n objects, and that will be coming out to be n factorial. Okay, now let's move to the some example. Maybe we can consider the example. Let's say you are having maybe 3 books, and you have to arrange these books on your table. Okay, so it will be simply 3 factorial. Okay, so that is coming out to be 6 ways. Very simple. Okay, the second kind of example, in which if I say there is some sort of repetition, let's say you are having the word B. You'll find the similar examples in our slide window, so the lecture notes that are available on the website. So we are having the word B. If you have to arrange the letters of this particular word, that will be 3 factorial. But you can see these two letters, they are like in the repeated format. So divided by 2 factorial. So I will be getting 3 ways only. So there is some repetition, then you just simply divide by that particular number. Like if I say that we are having some k, a, for that one, this will be like 1, 2, 3, 4, 5, 6, 6 factorial over. This is repeated 2 times, this is repeated 2 times. So 2 factorial into 2 factorial. That will be the number of ways. So that's how we deal with the concept of permutation. Okay. Moving ahead, we have the concept of combinations. Combination. So in this one, we are just going for like selections. So you can simply see selection. And in this case, the ordering, order doesn't matter. Like we are not concerned in which order we are just going for the arrangements or the selections. Okay. So the basically, if you are given like n objects and we have to select r objects, then it will be coming out to be NCR. That is extended like n factorial over r factorial n minus r factorial. And remember the basic concepts of mathematics, that 0 factorial, that will be 1, 1 factorial, that is also 1. So that's how we deal with like the combinations. Okay, let's take some examples for this concept also. Okay, so let me consider one example that you are having maybe you are having maybe 5 pens and you have to pick maybe 3 pens. So how many possible ways will be there? So that will be 5C3. Very simple concept. Okay. Then there is one more example that you'll find in the case where there is some repetition. So just consider that you are given like maybe you have to choose 3 balls, given that we are given 5. We are given 5 different balls. And in this case, if I say you can allow the repetition. Okay, repetition. Okay, this is slightly different. In this concept, like you can just say that we are having pen A, B, C, D, E. So you can only pick A, B, C, then A, B, D, then A, B, E. No repetition was allowed. But if the repetition is allowed, then this will be coming out to be N plus R minus 1 C R. So R concept, that is like N is 5, R is 3. So 5 plus 3 minus 1 C 3. So that will be coming out to be 7C3. That will be the case when we go for the repetition in the concept of combinations. But generally, when they go for like combinations, then there will be no repetition. But that is the formula that you can follow, and there is some repetition that has been allowed. Okay, so that is the concept of permutation and combination. Okay, I hope that makes sense. Okay, so this was more about like the concepts that we deal in the combination and permutation for the course of probability theory, and just get to know what is the meaning of combination and permutation. That's it in this particular lecture. This was very basic lecture, and maybe the timing is also like very, very low for this particular lecture. I hope you're able to understand how to deal with permutation and combination. Moving ahead, we are going to deal with much advanced topic in the probability. In the next lecture, we are going to deal with maybe the total probability theorem, the Bayes theorem, or maybe the conditional probability, the independent events, those kind of concepts. Okay, so that's all for today's lecture. Thank you. Bye.